Welcome to our channel, my dear students. Today we are going to talk about the previous year, that is last 10 year CBSE board chemistry questions part 33, in which we are going to discuss about the aldehydes, ketones and carboxylic acid chapter. So here the question number 1 is convert the following, that is ethyl cyanide. So we have to be very careful. Ethyl cyanide, while writing this structure, CH3 CH2 CN, this is ethyl cyanide. So this may be otherwise called as, usually organic cyanides are otherwise called as nitriles. Why the organic cyanides are generally called as nitriles? Because here they are giving ethyl cyanide, so that ethyl group and cyanide group is there. Suppose they are giving ethyl nitrile, that time you have to include this carbon also. So 2 carbon atom containing cyanide, that is ethyl nitride is different from ethyl cyanide. Are you able to understand? So this is very much important. So we have to, while writing the cyanide structure, if they are giving ethyl cyanide, there is no problem with that. If they are giving ethyl nitrile, at that time you have to be very careful. Total number of carbon atoms are 2 in that case. In this case there will be 3 carbon atoms, because they are giving ethyl cyanide. So that is what we can take this as a ethyl cyanide, and we have to convert this into ethanoic acid. Ethanoic acid, CH3COOH. So we must be very careful on this, because in reactant side we have 3 number of carbon atom, but product side we have only 2 number of carbon atoms. So we have to check. So if we want to reduce the 1 number of carbon atoms, we have to use one of the step, we have to use Hofmann bromamide reaction, degradation process. If you do that, we can reduce 1 number of carbon atom. So here, if you need to get a Hofmann bromamide reaction is nothing but it is a conversion of amide into amines. Okay, first of all we have to convert these into amide, then we have to convert these into amine. That is the idea. So here I have to convert this cyanide into amide. So nothing but we can do partial hydrolysis in presence of either acid or in presence of base, acid or base, in presence of partial hydrolysis. This is a partial hydrolysis. So if you do partial hydrolysis, you will be getting the product, that is CH3 CH2 C double bond O NH2. Once I got this product, so this is nothing but an amide. Okay, so if I got this amide, I have to do Hofmann bromamide reaction in presence of sodium hydroxide or KOH in bromine. So bromine KOH or bromine NaOH, which gives a Hofmann degradation agent. So I'll be getting the product, that is CH3 CH2 NH2. Nothing but it removes this carbon atom. So if you want to reduce 1 carbon atom, that we had at that time we had to use Hofmann bromide degradation. So here, once I got a amine, so if I got a amine, but I need to convert into acid, so we had to convert these into alcohols. So how we can convert into alcohols? So here it is nothing but I had to use NaNO2 HCl. If I use this reagent, I'll be getting this product, that is CH3 CH2 N2 plus Cl minus. Okay, what is that? It's a diazonium salt. Once I got this diazonium salt, if I hydrolyze with water, I'll be getting CH3 CH2OH. I'll be getting an alcohol. If I got an alcohol, then I'll do oxidation in presence of strong oxidizing agent, potassium dichromate, in presence of an acid medium. So in presence of acid medium like sulfuric acid, if I do this at oxidation, I'll be getting my product, that is CH3COOH, that is ethanoic acid or acetic acid. Are you able to understand, student? This is very much easier, but we have to do very carefully. So here the conversion, we have to reduce the number of carbon. So here 3 carbon atom containing reactant is there, but I have to convert with 2 carbon containing acid. So for that we have to reduce one more carbon atom. So by that way I used Hoffman bromide degradation. And question number 2 is butane 1-ol to butanoic acid. This is very simple. Butane 1-ol, that is nothing but CH3, CH2, CH2, CH2OH. This is butane 1-ol. So I have to convert this butanoic acid. This is very simple. So I have to write the reagent only. So CH2, CH2, COOH. This is butanoic acid. What I have to use? I have to use a strong oxidizing agent like this. That is K2Cr2O7 in presence of acid. So strong oxidizing agent will oxidize my compound alcohol into acid. And next one is a benzoic acid to metabromobenzoic acid. So here we must be very careful in this. So here benzoic acid. What is benzoic acid? I have to write the structure like this. This is COOH. This is benzoic acid. But I have to convert what is the product. So metabromobenzoic acid. So we have to be very careful. Metabromobenzoic acid. As we know that, I think so you know very well about the ortho, meta and para position. If you don't know about this ortho, meta and para position, please go and watch my video. Previous video, I'll be giving an icon. That will be available in the top right of this video. And here, what is that? Benzoic acid to metabromobenzoic acid. So we have to identify which type of groups are ortho directing and which type of groups are meta and meta directing, which type of groups are para directing. So we have to find out with a simple trick like ortho and para directing and meta directing. So if you don't know about this concept, please go and watch my previous video. I'll be giving an icard. So that will be available in this video. With the top right corner like this in this position. So you'll be getting an icard. So you just click the icard, you'll be getting the video about how to find ortho, meta and para position, para directing groups with a simple trick I already given in that videos. Thank you. And here benzoic acid, how we can convert this benzoic acid into metabromobenzoic acid. So usually if we know that bromination, what is a brominating agent? That is Fe, Br3 and bromine. If you do this, I'll be getting meta position. So I'll be getting if I used a carboxylic acid in this position, this will be a meta position. So I'll be having metabromobenzoic acid. Just by the bromination, I'll be getting meta, because carboxylic acid is a meta directing group. That is what this will be substituted in meta position. Our next question is methyl benzene to benzoic acid. This is also very simple. Methyl benzene to benzoic acid. Methyl benzene, what is a methyl benzene? Methyl benzene, or otherwise called as a toluene. Okay. So CH3. So methyl benzene to benzoic acid. How we can convert? So benzoic acid. This is the structure of benzoic acid. COOH. So just by the strong oxidizing agent. But strong oxidizing agent, that is if I use either KMNO4 in presence of KOH. So alkaline KOH will convert this methyl group into acid group. It's a strong oxidizing agent. And the very most important thing, arrange the following with increasing order of a boiling point. As we know that the boiling point is direct, as we know that very well, that is the boiling point is directly proportional to molar mass. If you don't know about this concept, please go and watch my previous video in alcohol chapter. So alcohol and haloarine chapter, you'll be getting good idea about this. So here they are giving same number of carbon atoms. One is aldehyde, 2 carbon containing aldehydes, and here 2 carbon containing acid and 2 carbon containing alcohols. So in which the boiling point will be very higher. So here in this case molar mass concept, as per the molar mass concept, so here the boiling point will be very high for some compounds. Say for example, if I am having acetic acid, it is nothing but the boiling molecular mass is 60 gram per mole. Okay. For aldehyde, so if we calculate it as it is a 54 gram per mole. If I calculate it for alcohol, that is 56 gram per mole. According to a concept, if molar mass is very high, the boiling point is very high. Okay, that is a simple trick. And the very most important thing is we have to look at the functional group also. So here the functional group is acid. Acid is having extended hydrogen bonding. In this case, it is having extended hydrogen bonding. But alcohol only having hydrogen bonding. But aldehyde, they having dipole interaction only. So in the intermolecular interaction also very weak in this case of aldehyde, but in the case of very strong in the case of acid. So if you numbering this one, this is 2 and this is 3. So if they are asking the increasing order of boiling point, we have to come from the lowest to highest. So lowest is 1. This will be very, very lowest one, and we have to move with that. Second one, that is third one, that is alcohol. So this is first question. This is why it has very, very low boiling point. That's what first one. And third, alcohol is the second one, and acid is a third one. So acid is having higher boiling point. It has very higher boiling point when compared to all other compounds. That's what. So increasing order of boiling point is given like that. Okay. And next question, write the product of the following. This was asked in the year of 2016. It's a very, very interesting question. So here dibol. So as we know that the diisobutyl aluminum hydride in presence of water. So if you do with this reducing agent, so I'll be getting some product. What kind of product I'll be getting? So the interesting product. So I'll be getting a product like this. That is so I'll be only writing the product. That is CH3 CH. This double bond will not be reduced. CH. Then CH2 CHO. Cn group is getting converted into CHO. This is a conversion of by using dibol as a reactant. And the very important question, why carboxylic acid does not give reaction of carbonyl group? Because the carbonyl group in carboxylic acid, that is C double band O OH, a carbonyl group in COOH is inert. This group is inert. Now this CO group, carbonyl group is inert. Why it is inert? That is what it does not show any nucleophilic addition reaction. Okay, are you able to understand, students? So here the carbonyl group in carboxylic acid is inert. That is what it does not undergo any nucleophilic addition reaction. But this is due to the reason of resonance structure, the resonance stabilization. Because of the resonance stabilization, the carbonyl group, that is a R acetic group, C double band O minus, that involving in the resonance structure, that is R CO minus double bond O. Okay, so this involving in the resonance structure, this is got stabilized. That is what it will not be involved in the reaction, addition reaction. That is what here the carbonyl group does not give any reaction of carbonyl group in carboxylic acid. Okay, that is the reason what we have to get it. First reason is the carbonyl group in carboxylic acid is inert, and another one is the resonance stabilization. Resonance stabilization of this COO group. Okay, that is what this will not be involving in any addition reaction. And next question is predict the following reaction. This question was asked in the year of 2015. So here the CH3COONA, some acetate, sodium acetate will be given in presence of sodium hydroxide and calcium oxide on heat. Once, as we know that once calcium oxide and heat will come, it liberates carbon dioxide as a gas. So by the way, I'll be getting CH3H, that is nothing but CH4. I'll be getting a methane as a product along with sodium carbonate Na2CO3 as a product. Are you able to understand, students? This is very simple one. Na2CO3, it's not SO3, CO3. Sodium carbonate I'll be getting as a product. And name the reagent. So that was asked in the year of 2015. That is acetic acid, which is getting converted into its respective acid chlorides. How we can do this? So this is nothing but CH3, C double bond O, H is there. So if I use PCl5, so as we know that the PCl5 contribution is, you know very well, I think so we can split like this, it's a shortcut. So PCl3. So I'll be getting a product that is CH3, C double bond O, Cl. Along with that, I'll be getting one molecule of HCl. With that PCl3 and O, that is POCl3 I'll be getting. Okay, I think so you understand very well. Thank you so much for watching. Please go forward to others to get benefit. Don't forget to subscribe my channel. Please give a like. Thank you so much for watching. Thank you once again. Thank you. Thank you for learning. Share and like this video.